Hello, welcome to the channel. Topic for today is to discuss how you define your functions in Clojure, and we'll start from real basics, like how you define simple function, what is anonymous function, and then we'll continue to more advanced topics like overloading, varargs, some best practices, etc. And we'll touch some rarely used features as well, so I hope everyone will find something interesting in this video. Before we start with defining functions, let's just discuss how you define anything in Clojure or like in Lisp. So we have a special word for that, which is def, and the form is pretty simple. You have def and then the name of what you want to define, like a global var, and then some value inside. So in this simple example, we have def x1, and then if you execute this x, you will have the value back. So let's move to functions, right? So for functions, we have our fn macro, and this fn will create a function for us. So the syntax for that in the most basic case is fn, and then we have a vector, and inside the vector you can put your argument names. So in our case, we have just one argument called x, and then we define the body of the function. And in our case, the body of the function is just to add 1 to our x input parameter. Let's actually rename it to something like arg0, just so it's not shadowing this x that we defined at the top. All right, so if we evaluate this block of code, we'll see that it's now returning an object in our REPL, and that's because this was evaluated and defined as a function, but we never defined it inside our namespace. So we cannot call the function that we created. And to call the function that we created, we need combine fn and def in this way. So now let's say we create our first simple fn, and what we have is now we combined these two forms together. We now have def, and that's the name of what we want to define. So our global var name will be first simple fn. And here as the value, we don't use simple value as 1, but we have another simple value, which is an object that is a function right now. So we define a function like this. If we execute that, now we have different output. And now we can actually call the function. So to call the function in Lisp, on Clojure, you open your S expression and then type function name, first simple fn. And as we said, it will accept one argument. We can put our argument here. And result, now we have 2 because 1 plus 1 is 2. To save us a bit of time and avoid this expression when we have def and then fn, there is a defn, which actually is doing exactly same almost. So we can rewrite this function in a defn form. So how to do that? We're changing def to defn, and let's name it differently, like let's say defn. That's just a function name. And here, instead of doing fn as expression, we're just moving our arg0 here, and we're putting body of the function straight after the args list. Let's call that one, and we can execute that again, but now we need defn, let's say 3, and we have a new output. So that's the most basic thing you can do in Clojure to define a function. And the thing to understand is that functions in Clojure are like a first class entities, which means that you can create them on the top level. So basically the only thing you need is your file with a namespace defined, and then you create just functions there, right? So the same idea exists in multiple languages, like in JavaScript. You can define functions on the top level as well. That could be something new for Java programmers, for example, because in Java, everything is inside the class. So your functions are actually methods inside your class definitions, and then you need to instantiate the object first and then call functions on top of that. Something more similar will be static functions that you still need to create a class, but at least you don't have to create an object of the class to execute the function. That's hopefully not the case in Lisp and in Clojure, because we just create functions on the top level, and then we can use them in multiple ways. We can call the function, but we also can pass function as an argument to the other function. So you pass the function as the first argument, and then inside your other function body, you can just call your function that was passed as an argument to the function. We'll take a look in these ideas later. Let's continue our investigation of what defn could do for us. So the other thing is, if we want to create some documentation for our function, we can create this string. We can add a string in between the symbol, the name of the function, and the args list. And after that, we can use a handy function called, it's actually in Clojure.REPL namespace, and it's like doc. And then you can provide your first simple defn, like a function name here. And if you execute that, you will see doc list of that function. It's nil now because there is no doc string, but we can fix that by doing it here. So you can say this is my doc string for the function. And we need to evaluate that, and we call this again. And now you see that we have our description here as well. The other way to access that is to call the meta function, meta, and pass the var of the function. So it will be first simple defn. And now we will see a bunch of stuff here, like arg list and doc. But if we just looking for doc, you can just do this doc on meta, and we have the doc string from the metadata of the var. All right, that's actually what I described here. Other things that you can define as metadata of your vars in general, but for us, we'll take a look into functions. So if you use a different macro here, defn with a dash at the end, it will create a private function for you. If you execute this thing and then we do meta var my private fn, you will see that we have private true, and this basically is added to the metadata. It's not like it's not as private as you would see would expect. For example, if in your Java class you define a private method, it will be really hard to execute that method. Probably it's possible if you do some kind of reflection or some other weird things to call that method. In Clojure, it's actually pretty easy to call a private function from a different namespace. It's not that easy as to call a public function, but it's possible. And the main reason of having this defn private variation is just, like to say for other developers that those functions are supposed to be used internally in this namespace, and they are not a public API of your library or of your code that you've written. So it's not supposed to be used easily from other namespaces. That's the main idea. There are different ways to add metadata. So there's a specific special macro here, but if you take a look here, what it's actually doing is it's using with meta, and then it assoc the private key with true value inside. You can actually do that yourself. So the other option is to use this special notation for metadata. So let's say we have p with just private like this, and if we do meta on var of p, we'll see same private true, and it's actually same for if you do map version, like let's say p1, and let's double check that as well. Meta var p1. Yep, you see the same true here. It's for private true. It has specific meaning. If you want to add any metadata here, you can do that, like my custom meta key, and let's say 1, 2, 3, right? If we execute this thing and call this again, we'll see a key like this added to the metadata. So there are some use cases for that. For custom metadata, for example, what I've seen is one of the usages is if you create different tests, you can say that, for example, like it will be a bit of pseudocode, but you can do def test, my test, and then something. But here in the metadata, you can add something like integration or something like that. So this will be integration, and then let's say you have def test unit, etc. And after that, in your test runner, you can configure it somehow to use this metadata to filter your test definition. It's not related strictly to function definition. It's more about metadata of vars in general, but it works for defn as well. All right, so we already touched a bit about arguments of the function, but let's create a new function here, defn my fn with args, let's say, and then we, in this vector that we have, we can define 0 or any number of args as we want. So with 0 args, let's say we have we just return an empty vector from the function. By the way, in this body, you can put whatever you want. So like you can have multiple lines here. So let's say inside my fn with args. Let's execute this thing. My fn with args. We now have this print line, and the return is empty vector. If we want more than 0 args, we can do arg 0. Name could be anything, so you can say x, you can say y, whatever. Let's say we have y0 or something, and then you put it here. And if we execute it once again, let's pass it 1, and it works. We now have the return of the vector with 1 element. If you put more than 1, now you have an exception saying that you passed the wrong number of args to your function. And again, if you have less than 1, you'll have the same exception. Now it says like 0 instead of 1. Yeah, you can do other args as well. 1 and 2, let's say. We have 1, 2. Let's execute this thing, 1, 2, 3, and we have all our args here. One of the common ideas in functions is if you have the list of args that is growing over the time, probably that's some problem with your design with arg as map. Let's say a common idea to fix that is to design your function in such way that some of your args are supposed to be maps, and you combine groups of your args into some meaningful entities. So let's say we have the first arg to be like dependencies, and let's like say like options at the end. And what this will allow us to do later is we now have our new function. Let's fix the print line. And then we have these dependencies and options. My fan with arg as map. And for dependencies, let's say I have database, say db connection, and maybe, I don't know, cache something. And then for our options, let's say we have some flag true, something like that. Now we have this, and what you can do inside your function definition, you can use destructuring. I have a dedicated video for that. Just take a look if you want to learn more. But in a nutshell, you just can do keys, and then let's say you're interested in just db from dependencies, and now you'll have db here. So if I execute it once again, I have db destructured, and for the options, same idea. You can do keys, and then let's say our like flag like this. So it's destructured correctly. If you still want access to everything, you can do as dependencies and flag as opts, and now you have access to both things as well. Still, let's say dependencies, opts. So now we will have a vector of 4 elements. We have these two destructured, and we have access to the entire thing that was passed into function. That's like just a best practice, because the idea is that if you keep your args list growing, each time you add a new thing, you need to refactor the entire code base that's calling the function to properly pass new params or pass some defaults or do the overloading. We'll take a look in a sec. If you group your things into maps, and you can just control it here with defaults, or like pass anything, and you just define in your entry chain of function calls that you like pass new data inside your map, and then you'll have access to all of those data in all your functions downstream. So other thing is overloading. And I try to describe a common pattern here. So note that we now group these definitions inside separate as expressions as just like a lists. And the idea here, let me just quickly remove this thing. I'll return it back, but just to demonstrate. So imagine we have a function that had no arguments, and let's say something. And then we want to create a new version of that, but it will take one argument. So what we can do is, if you go here and just insert a new as expression and just wrap this thing, and then you can add multiple of those. So let's say we now have a version with arg0, and it will return just like arg0, let's say. And here, if we want to reuse our implementation of one argument function, you can call your function right here. So it will be do something fn, which is the name of our function right here. And then we can pass some default as we want, like arg0, hard-coded here. And you can go deeper, like additional version of that, arg0, arg1, and again, you can now here just call the do something function with 2 args, arg1, like that. I just roll back to my previous example. It's same idea. So we have a function with 0 args, and all 3 args will be passed as defaults, like this. Then we have version with 1 argument, 2 and 3. And in our most generic implementation, we just print line args and this entire arg list. So if I call my do something function with no args, it will be all defaults, all these keywords. If I call it with one argument, it will have 1 here with 2 arguments. You can imagine 1 and 2, and then with 3 arguments, it will have nil. The thing is that we try to add more arguments, we'll still get the wrong number of arguments exception. And you can fix that by using varargs. A special symbol here, pay attention. We have one expected argument all the time, but we have additional unlimited number of arguments after the first one. And let's demonstrate that. So if we call fn with varargs and we pass 0 args, we have an exception. If we pass 1 argument, we'll have everything working correctly. And note that these args will be nil because nothing was passed right here after 1. But if we do 2, now these args will be a sequence of rest of the arguments. So the first argument will be mapped straight to this named argument, but everything else will go here into the rest. And you can grow it like this, 4, and in that case, you basically look into this argument list as a sequence, and you take the first one, map it to your arg0, and then you have the rest mapped to args. And this is varargs in Clojure. One of the cool ideas, and some people just using that a lot, is to use keys. So destructuring, if you know how that works for varargs as well. So here, what's going on is if we provide key X and key Y, it will be mapped to these specific vars inside args, but it will also have access to all arguments as well. Let's demonstrate that. So we have our fn with varargs2, and now we have, like, say 0. X, Y, and args are nil, but see what happens if we put X and 1. So now we have 1 here, which is our X value, and this is because this destructuring worked. Y is still 0, and rest is just a map, because this inlined definition of this rest of the args is actually converted to a map right here if you do varargs. If you add Y to, now we have both things mapped together. You can add more, like add 3, for example. We don't have a specific binding here for Z value, the Z key, but it's still accessible by entire args here. I think in some recent Clojure, I could be wrong, but probably from Clojure 11, you can actually combine this into a map. So it doesn't matter from Clojure point of view if you're doing it without the map here or with the map. So if you call the same thing with the map, it still works exactly the same. Probably that was not the case in previous versions of Clojure, but I could be wrong, so double check that. Moving next, a specific use case, but you can use this type hint to define the return type of your function. So in this case, you can do this special character and then type, and you could put it both before the definition of your function name or before the arg list. And there are some discussion in this link. I'll probably just put it in the description of the video so you can double check. One use case I see for that, I don't really care much about, like type conversion and all that stuff, because in apps that I write, that's not the biggest problem. Like, it's not a bottleneck, so I don't really care. For some people, that probably could be a reason, but for me, one of the use cases of this return type hint is when I'm doing some Java interop, and my editor is basically not recognizing the Java method because it doesn't understand which type I'm trying to provide inside. And in that case, if you type hint your function that you're trying to use, the editor starts to understand what you're trying to achieve and stop complaining about your code. Next thing, be really careful with this one, because just because you can do that, it's not always the right thing to do. But this, I tried to implement some most dumb version of Fibonacci sequence here. So we have a case condition here, and we just mapped some start of the sequence. But after that, we just do plus, and I call recursively the same function with an decremented and decremented twice, and just sum that, which defines our Fibonacci sequence. And the problem here is that if you call function recursively like that, the tail call optimization will not work. It's a fancy term, but the thing to understand is if you have a huge list of calls like this, it will be all on the stack, and at some point it will have the stack overflow exception, same as the website name, the popular one. And there is no way to avoid that if you call just function recursively. So the better option will be just to use loop recur, which is a explicit way to define recursion. But in that case, you need basically to rewrite your code with this special form. I actually have a detailed video on the channel already about loop recur and how to use that. So if you want to learn more, search the channel for the loop recur video. Not many people know that if you're using anonymous function with just fn without defn, you can still provide your function name as your first arg, and you can still refer to your function if you want inside the body by that name. So fib1 here is just the name of this anonymous function, and I'm able to define recursion here inside an anonymous function as well, just to prove that if I remove this thing, this now will be undefined, right? And then there is a shorthand syntax form for anonymous functions. And let's say one of the examples, let's say we use map, and then we have a sequence of 1, 2, 3. And let's say you want to add 2 to each of these elements. The more verbose way of writing that will be just say value, and let's say plus v2. Let's execute this thing. Now we have 3, 4, and 5. Some people don't like this more long version of defining functions, and there is a short version of that. But personally, I mostly prefer to use fn version of that because I really hate how it looks. But if you really want, you can do this. So now you can just define function right here, and with this % symbol, you'll have access to your argument. So this will be v in our previous definition, and then you can say 2, and it will do exactly the same. So 3, 4, 5. Let's say we want to add 3. Again, you can reuse this thing if you want to just sum it twice or 3 times. You can do like this, and it will be 3, 6, 9, right? Yeah. So that's the syntax for that. If you have more than one argument to your anonymous function, you can use %1, %1, %2, %3. Let's say I define it here. The name is my ugly fn, and I call it. I have 6, which is some of these arguments. If I do 4 here, it will have an exception because my function was defined with 3 arguments here. Again, I don't really like this syntax, but that's my personal taste. So, couple more things here, which is I really rarely use in my day-to-day work, but probably good to know, is that you can define your pre and post conditions as part of your function definition. So I created this one. So to create a precondition, you can define a list here in the map. It should go after your arguments definition. So it's like pre, and then in the list you put different conditions that you want to check. So in this case, I tried to create a function that will accept only values 42 and 10 for these 2 args. So let's say x and y here, and let's call this function. So let's say we have 42 and 10, and this should work. But if I put anything else, it will fail with an assertion failed. That's for pre-condition. You can put different conditions as you want. So it's like sum of arguments now should be 10. So it's like 1 and 9 should work. 1 and 10 should fail. And yeah, like positive input, stuff like that. So actually that's post. So in this function, I try to define that function should return a positive integer. And now I'm using this post keyword. And again, the idea is same. You can create a list of conditions that you want to check. And here, instead of accessing the input arguments, this ampersand will refer to return value of the function. So let's execute this thing and should return pause. And as you can see, I'm passing x and I'm returning x, so I can control what the function should return. So if 10, it should work. If minus 10, it will fail with an assertion as expected. We almost at the end. So couple other ideas for functions is that we mentioned that before, that you can wrap your functions, you can pass your functions as values, but an interesting thing here is you can return a function from the function. So, and this is called Clojure. And like definition is right here. So the return function from form adder is a closure, and this means that it can access all the variables that were in the scope when the function was created. So to understand that is we have this function adder, and if we pass x there, it's not a part of this function that is returned from the first function, but it was known at the time of the creation here. So the idea is that we have this adder, and then we define a different function. So we do the def here, not defn, and adder 5 will return a function for us that will always add a 5 to whatever you pass as an argument to that new function. So if we do add 5, and then we call that function, it will be 105. Because this is a function now created right here, and we know that we always should add 5. So that's the idea of closures. Yeah, and I think the final thing is sometimes you have your function definition like this, but you don't use one of your args in your function, and you don't want to refactor that for some reason. Same as in lets or other parts. If you use some linter that could leads to complaints, to ignore the var, you can just do underscore, and in that case, your linters will be fine. But you cannot also fully ignore the var by just putting the underscore like this. And yeah, the last one is, as I said, you can pass your functions to other functions. So let's say defn, apply fn, fn example. And let's say we passing fn to apply and then the value, right? And then we do fn to apply and value, like like a pretty stupid example, but you'll get idea. So here apply fn example. Let's say I want to apply increment to value 1, and I execute that. I have 2. So I pass the function inside the function, and they then call it inside the function. So that could be hard to understand if you're just coming from strict object-oriented programming without any functional concepts. But it's good to understand that it's possible in Lisp and in Clojure, and you can use that in your code as well. That's it for the video. Don't forget to subscribe, like, and comment. And also you can support my channel on the Buy Me a Coffee page. Thanks a lot for watching, and see you next video. Bye-bye.